Hello students, in previous classes we have seen about the rational numbers and different concepts related to that, and in last class we have seen the representation of rational numbers on the number line. Now we will see the decimal representation of the rational numbers. Okay, for decimal representation we convert the rational number to decimal, and by division method we will do that. Okay, these decimals are two types decimal numbers. We have terminating decimals. Terminating means there will be end, and non-terminating, there is no end for non-terminating decimals. Okay, non-terminating or recurring decimals. Okay, example for terminating decimal. Okay, for example 3.5. Okay, this is the example for terminating decimal. And what is the example for non-terminating decimal? Non-terminating recurring decimal. Okay, this type of decimals don't have any end. For example 7.6655, like this. Okay, it goes on, it don't have any end. Okay, the point continues. Okay, now first we will see this is terminating decimal and this is non-terminating recurring decimal. Okay, first we will see how to convert the rational number to decimal by division method. Okay, now we can see here convert the rational number to decimal by division method. Okay, we are taking a rational number and now we will proceed with the division method. Okay, 16 is the divisor. Okay, divisor. 25 is the dividend. Okay, and here we get the value that will be the quotient. Okay, 16 ones are 16, we get 9. If we take borrow, then 15 minus 6 becomes 9. Now this number, the dividend is less than the divisor. Okay, if the dividend is less than divisor, then now put a decimal point in the quotient and add 0 here. Okay, we take zeros now. 16 how many times becomes 90? 16 5s are 80. So 5s are 80, 80. We get 9 minus 8, 1, 0, 10. Okay, already we have taken the decimal point, so we can add one more 0 here. Since the dividend is small than the divisor, okay, we can't do further, so we should take one more 0 here. Now 16 6 are 96. Okay, 6 are 96, we get the remainder 4 here. Okay, still again dividend is smaller than the divisor, so as we have a decimal point, we can take one more 0 here. Take one more 0. 16 3 is a 48, so 16 2 is a 36. Sorry, 32. Okay, 10 minus 2 becomes, if we take here carry 8. Okay, 8 still it is smaller number than 16. So as we have decimal point, take one more 0 here. Okay. Okay, here we got here 16 5 is 80. Okay. 5 is 80. 80 minus 8 is 0. At last we got the, this is the remainder 0. Okay, until we get the remainder 0 we did, and this is the quotient. Okay, now this rational number value is 1.5625 in the form of decimals. Okay, therefore 25 by 16 is equal to 1.5625 in decimal form. Okay, this is a terminating decimal since we got remainder 0. Okay, if we don't get the remainder 0 and the numbers goes on continuing, then that such type of numbers are non-terminating recurring decimals. Okay, here we got the remainder 0 and we got the exact value, so this is terminating decimal. Okay, students, we will see one more example for the terminating decimal. Okay, first what we should do, first write down the divisor and dividend. Okay, 5 and 17. Okay, this is divisor and this is dividend. Okay, do until the dividend is less than the divisor. Okay, 5 3 is 15. 7 minus 5 becomes 2. Okay, now this number dividend is smaller than the divisor, so in this case add a decimal point in the quotient and add 0 to the dividend. Okay, 5 4 is 20 until we get 0, until we get the remainder 0. This process should be continued. Okay, we are not getting 0 and the numbers are repeating again and again, then that type of decimals are called non-terminating decimals. Here we got the remainder 0 and we got the exact value, that is the rational number 17 by 5 is equal to 3.4 in the form of decimals. Okay, this is also example for terminating decimal. Okay, now we will see the non-terminating decimals. Okay, students, now we will see how to convert the rational numbers to decimal form for the non-terminating decimals. Okay, this is non-terminating decimal or non-terminating recurring decimal. Okay, here we are having an example 5 by 3. Okay, similar to the terminating decimal, we will proceed with the division method. 3 is the divisor here and 5 is the dividend. Okay, 3 ones are 3, 5 minus 3 becomes 2. Okay, now since the dividend is smaller than the divisor, now put a decimal point in the quotient and add 0 here. 3 how many times goes with 23? 6 are 18, 3 7s are 21, so it is not possible with 7, then 3 6 are 18. Okay, 20 minus 18 becomes 2. Again 2 is smaller than the 3, so as we have already decimal point here, add one more 0. Okay, again it becomes 6 18. Again remainder 2. Again as we have decimal point, we can take 0. Again 3 6 18. Okay, this is never ending process. Okay, if we observe, it is repeating, going the remainder 2, we are getting always the remainder 2, and after decimal point we are repeating with the number 6. Okay, this is a never ending process. Okay, this type of rational numbers are non-terminating rational numbers. Okay, 5 by 3 is equal to 1.666, so on. Okay, this is example for non-terminating recurring decimal. Okay, here now instead of repeating these many times, we can simply put 5 by 3 is equal to 1.6 bar. Bar denotes the number is repeating many times. Okay, instead of, for these non-terminating decimals, instead of repeating many times, we can simply put a bar here. Okay, this is bar. Bar denotes repetition of number. Okay, this is non-terminating decimal. Okay, we will see one more example, 1 by 7. Okay, now 7 is the divisor and 1 is the dividend. Okay, here we can see the dividend is small than the divisor, so just put a 0. 7 zeros are 0. Okay, further then add a decimal point. Okay, after adding decimal, take a 0 here to the right side of the dividend. Now 7 ones are 7. 10 minus 7 becomes 3. As we have decimal point, we can take one more 0. 7 fours are 28. Okay, 7 fours are 28. We get remainder 30 minus 28. Okay, 10 minus 8 becomes 2. Again we are having decimal point, so we can take one more 0 here. 7 3s are 21, so not possible. 7 2s are 14. 10 minus 4 becomes 6. Okay, again 6 is smaller number than the divisor, so again take a 0 here. 7 7s are 49, 7 8s are 56. Okay, we can take 8 here. 56. Now again 10 minus 6 becomes 4. Again we can, as we having decimal point, again take one more 0 here. 7 5s are 35. Okay, again 10 minus 5 becomes 5. Again 5 is smaller than the 7, so take one more 0. 7 7s are 49. 50 minus 49, 10 minus 9 becomes 1. 1 is again smaller number than 7. Okay, we got 1, this one here now. Okay, so again take 0. 7 ones are 7. Okay, 10 minus 7 becomes 3. Okay, same here. Now it is repeating. Here we got 10, next 3. Okay, we are adding again. As we having decimal point, we can take 0 again. 7 4s are again 28. This is a repetition process, never ending process, so it goes on like this. Here also these numbers are repeating. 1 4 2 8 5 7. Again this number is again repeating. 1 4, again 2 8 5 7. Up to 5 7 the numbers is again repeating. So this is non-terminating. Okay, next we get 20. Again 14 minus 14. Next Again if we subtract, we get 60 minus 56. Okay, this process is going on. Now 1 by 7 is equal to 0.14285714 and so on. Okay, now we put a bar from 142857. Okay, this is equal to 0.142857 bar. Okay, this bar, the numbers in this bar are repeating again and again. This is also an example for non-terminating decimals. Okay, students, simply remember one thing, that if in the first step itself the dividend is smaller, okay, here 1 is less than 7. In such type of numbers in which the dividend is smaller than the divisor, just directly put a 0 and take a decimal point and go on adding zeros to the dividends. Okay, only in the case of the dividend is less than the divisor, in the first step itself just put a 0. Okay, this is about the non-terminating and non-terminating decimals. And for this we are having a new concept again for non-terminating decimals, that is period and periodicity. Okay, what is period here? The numbers which are repeating. Here this is the repetition. Okay, this is the period. Okay, now we will see the concept of period and periodicity. Okay, here in this non-terminating decimal we have period is equal to this repeating number is the period 142857. Okay, this is the period and its periodicity will be, how many are there here? 1 2 3 4 5 6. 6 will be its periodicity. Okay, we will see them clearly now. Period is the repeating numbers or number or numbers. Okay, now the set of digits which repeats in non-terminating recurring decimal is called period. Okay, repeating numbers are period. Example 0.33333, so on. Okay, here 3 is repeating many times, so we can write 0.3 bar. Okay, we are having bar on 3, so now period is equal to 3. One more example, 0.12757575 and so on. Here 75 is repeating many times, so we can take 0.1275 bar. Okay, now here period is equal to 75. Okay, this is about period. Now if we see the periodicity, what is periodicity here? In same examples, if we take first one 0.3 bar, okay, period is 3. Now periodicity will be, how many numbers are there in the bar? Okay, how many numbers in the bar or repeating numbers? Okay, how many numbers are repeating? Those are the periodicity we take. Here only one number is repeating, so periodicity is 1. If two numbers are repeating, then periodicity will be 2. If three numbers are repeating, then periodicity will be, therefore period is equal to 7, 5. Periodicity is equal to, here two numbers are repeating, so 2. Okay, suppose if three numbers are repeating, some 0.575 bar. Okay, three numbers are repeating here. Here period is equal to 575 and periodicity will be, three numbers are repeating, so 3. If four numbers are repeating, then periodicity will be 4. Okay, for example, in previous we have seen here how many numbers are repeating? 1, 2, 3, 4, 5, 6 numbers are repeating, so we take here periodicity 6. Okay, this is about period and periodicity. Okay, we will see the next topics in the next video. Okay.